Hey guys, Mr. L here, coming at you with another video. In this video, we're going to talk about the major ways chemists separate compounds. We're going to talk about the three major ways, the first of which is going to be filtration. Secondly, we're going to talk about distillation. And third, we're going to talk about chromatography. So share this video with your grandpa, share this with your cat, and let's get into it. Alright guys, so here we have an example of filtration. So I have a very simple filtration apparatus set up here. I've got my ring stand, I've got an iron ring with a clay triangle and a short stem plastic funnel. And then to collect my solvent or whatever liquid I'm trying to isolate, I've got an empty beaker here. Here I've got my heterogeneous mixture. I've got some volumetric flask caps mixed up with some water, and I really want to isolate my caps out. I want my caps back. So what I'm going to do is I'm going to use size exclusion of this pour in this funnel to isolate my caps. So I'm just going to begin to pour my solvent through here. And there we go. Now I've isolated my caps from the water based on size exclusion. Now I can just put my isolated caps back in the beaker, and there we go. That's filtration. The next technique we're going to look at is called distillation. And the way distillation works is separating compounds based on difference in boiling point. So this is a distillation apparatus we have set up in the fume hood. On the left side, over here, you can see that we have the boiling flask that's being heated by a heat blanket. So what's in this boiling flask is we've got some salt and some water that's been mixed together. And if we wanted to isolate the salt crystals from this solution, we could select the lowest boiling point of the two. Of the two of these, water has the lowest boiling point. So we can set this to about 100 degrees Celsius, have the water boil, and all of the water vapor is going to go up and through this middle section here called the condenser. The condenser has water, cold water running through it from the right side of the video to the left side of the video. And what this is doing is it's cooling off the water vapor that's been isolated from the boiling flask in order to recondense it back into the collection flask, which is the one all the way on the right side of the screen. So this is distillation, and it's separating compounds based on boiling point. So the last separation technique we have here is called chromatography. And there's many different kinds of chromatography. You have paper chromatography, thin line chromatography, which is a plastic plate with silica gel stuck onto the plate. You have high performance liquid chromatography, ultra performance liquid chromatography, gas chromatography, and all sorts of different ones that you could experience. They all work the same way though. There's two things that you need to keep in mind when you're talking about chromatography. You need to talk about the stationary phase and the mobile phase. So if we're talking about the stationary phase, that's the phase within whatever column or device that you're using that is not moving. In this case, I have a column. So we're going to do some column chromatography, and we've got a resin packed in this column, and this resin is not going to move. That's this white substance in the column. And we're going to imagine we have some solvent that we're going to pour over the column, and we're going to collect in this beaker. That's our mobile phase. Your mobile phase could be water, could be ethanol, hexanes, whatever kind of liquid solvent you want to use to pass through this. If you're doing gas chromatography, your mobile phase is going to be a gas. All right, but it doesn't really matter what you're using as long as you have a stationary phase and a mobile phase. So let's run a thought experiment here. We have the sample, and we're going to put this sample onto the column in order for separation. So we're going to load the sample here. And let's say our sample is made of three colors. So it kind of looks all brown, blackish to begin with. It's all mixed together. We don't know how many colors there are, but I'm telling you there are three. And the three colors that we're going to have are blue, yellow, and red. So we load our sample, and we begin to pass solvent or mobile phase onto the sample. So what's going to happen over time are these analytes are going to begin to separate. So let's say that the blue sample barely moves at all from the top of the column. Even though we've been running mobile phase over it, the blue sits at the top. It's highly attracted to the stationary phase. The yellow one may be in the middle of the column, and it's got slight attraction for the mobile phase, but slight attraction for the stationary phase. And then the last analyte, the red one, came off quickest, and we've already collected it in the beaker. It has the highest affinity for the mobile phase. You're going to want to select the best mobile phase and stationary phase to best separate your analytes and collect them. So there it was, guys. This was the video on chemistry separation techniques. If you enjoyed the content and found value, smash the like button, subscribe, share it with your neighbor, share it with your friend. Let's get this to the top of the YouTube algorithm, and we'll see you in the next video.